would then go into the cable modem or DSL modem to be transported across this internet service provider's access network in that metropolitan area. And the IP packets would flow through the high-speed connection over the access network, and then they would get to a point of presence which would connect this IP access network from the internet service provider to the internet. And in theory, the IP packets would then be transferred onto the internet and they would travel long distance. Now at the other end, the other person has a regular telephone and they don't necessarily even have an internet connection. So what we need at the other end is a device that can convert the voice in IP packets into regular telephony. And as we're going to see as we go through the course, this device is called a gateway. So the company that's going to offer this service has to deploy these gateways in all of the major cities, well, all of the places where they want to provide regular telephony, so that at the far end we receive the IP packets and turn them back into regular telephony to deliver it as a regular phone call at the far end. When this was announced, it was characterized as internet telephony. So the idea is that you're going to have an internet connection, you're going to talk into a regular phone that's plugged into an adapter that changes your communications into voice over IP, and then those IP packets will travel across the internet to a gateway at the far end. Not. The problem with using the internet is that there are no quality of service guarantees. So a company like Cox Cable is going to go on this huge capital investment to deploy all of the infrastructure to do this. They're going to go on a huge advertising campaign. They're going to build all of the systems for billing and managing customer accounts and troubleshooting, all of the interconnections, and then they're going to run the IP packets over the internet in the middle, and the users are going to complain about the sporadic, spotty quality of service. I don't think so. If they're going to go to all the trouble to deploy this, the bottom line is that it has to sound as good as a regular phone call, or else people are going to initially sign up and then start disconnecting and going back to regular telephony, and it'll be a huge disaster. So what they need to do is to come up with some guarantees of quality of service. One way of doing that would be not to use the internet as the wide area network in the middle to move the packets across the country, but instead use a managed IP network. And we'll cover this as we go through the course, but the short answer is that a managed IP network is one that uses all the same protocols as the internet, but it's not the internet. It's a commercial version of an IP network. And what we mean by commercial is that the access to this is very carefully controlled. We don't have zillions of people with dial-up and DSL connections sending packets willy-nilly. No, this is separate capacity and separate equipment put in place by a service provider where they control who's allowed to send IP packets across this network. And because they can control who sends IP packets, that means that they can do some traffic engineering, and that means that they can start talking about some quality guarantees. So that's one possibility. The internet service provider will either deploy a managed IP network coast to coast and deploy all of the gateways at the far end, and they'll go on this huge capital program to build all this stuff so they can do telephony. Another choice, of course, is that they would stick to what they do, which is access the last few miles, and then they would partner with some long-distance company that already has a managed IP network in place to move the packets long distance. But they still have to have these gateways at the far end. Now that's going to cost a lot of money, and it's going to take a long time to roll out. You know what the cheapest way to guarantee voice quality would be? Is at the earliest opportunity to take this voice over IP phone call. So on a box 2 miles away from your house, we would deploy a gateway, and at the earliest opportunity we would convert it to a regular phone call, which uses streams of bits at 64 kilobits per second, called a DS0 channel. and then we would transport it just like any other phone call across the regular telephone network. This is the easiest and cheapest way to guarantee quality of voice, and it means that we don't have to deploy gateways in all of the far end cities everywhere on the planet. We only have to deploy gateways where we're providing this voice over IP access service. So you can bet dollars to donuts that's how it's going to actually start. Now the question comes back, why was this portrayed as being internet telephony and voice over IP long distance over the internet? Mostly for regulatory reasons. If we say that we're providing plain ordinary telephone service, then we're subject to regulations and fees that are imposed on plain ordinary telephone service, such as the universal service fee. But at the beginning of this voice over IP over the internet story, there are no regulations. It's an unregulated area. And so if we say that we're doing it over the internet, then there are no universal service fees, so they can provide it more cheaply. Now, of course, the regulators are going to figure this out. I mean, what I'm saying here is not something that I just came up with. The regulators are going to realize this, and then they're going to take a close look at these networks and see exactly how they're doing the long distance and find out that, well, what they're doing is they're taking the voice over IP and turning it into a circuit-switched regular phone call and sending it over regular inter-exchange carrier networks, and it's going to get regulated pretty soon. Even if we start sending the IP packets over a managed IP network, then the regulators have a lever to get in there and say, well, it's not going over the internet, it's going over this commercial data network. So that's not an unregulated service. We're going to get in there and regulate it, and we're going to make you pay the universal service fee. So as far as I can tell, the reason why it was called internet telephony was to try to avoid regulation. But that's not true, and it's not going to last very long. The purported advantages of this kind of voice over IP are, first, of course, that it's going to be cheaper, and then second is we can start providing some value-added services compared to plain ordinary telephone service. The reasons why this might be cheaper, number one is no regulation, so therefore no universal service fees. That's not going to last for very long. Another reason why it might be cheaper is that we are bypassing the local exchange carrier on the access part of this story. And this is a significant point because in the United States, when you make a phone call, the local exchange carrier adds a charge to the long distance phone call, a per minute charge for using their wires to get to the inter-exchange carrier. And in some places this can be as high as 7 cents a minute. Most places it's less than that, but it can be a significant amount of money that the local exchange carrier adds. And if we can just bypass the local exchange carrier by doing the access over a cable TV network, well, right away we can eliminate that 4, 5, 6, maybe even 7 cents a minute, and then it's definitely going to be cheaper. Another reason why this might be purported to be cheaper is because of statistical multiplexing. Now, we're certainly going to discuss this as we go through the course, but the basic idea is that instead of reserving capacity on the long distance circuits all the time during your phone call, whether squeaking noises are coming out of your face or not, if we use a variable rate vocoder, and a variable rate vocoder means that if squeaking noises are coming out of your face, bits get transmitted. If no squeaking noises are coming out of your face, no bits get transmitted. If we do this, and that's an if, what that means is that if no squeaking noises are coming out of your face, you're not using any capacity on the backbone. Somebody else can use that capacity. And we start thinking, well, during a phone call, what percentage of the time are squeaking noises coming out of your face, and what percentage of the time are you doing nothing? Well, right away you're listening half the time. So right there it's 50%. And then with all of the spaces between the words, we might get down to a number like 40% of the time squeaking noises are coming out of your face, 60% of the time nothing is coming out of your face.